The diagonal of a TV set is 52 inches long. Its length is 28 inches more than the height. Find the dimensions of the TV set. Make sure you show your work to receive full credit. So I'm going to draw a picture so we can label some information to start. We're going to have a television set, which has a diagonal of 52 inches. The television set is a rectangle. And it's also stated here that the length is 28 inches more than the height. So let's say this is the height, and the length is 28 inches more than that height. And we want to find the dimensions of the TV set. Now, because the TV set is in the shape of a rectangle, I know that this angle is a right angle, and the length and the height of the television set along with the diagonal form a right triangle. So we can use Pythagorean theorem to relate the sides of these of this triangle. So I know that with Pythagorean theorem, you have the legs of the triangle, which are A and B, and the hypotenuse of the triangle, which is the side opposite of the right angle. And the way the sides relate is A squared plus B squared equals C squared. So notice that we take the legs, square them, and add them up, and that's equal to the diagonal squared. In our example, the side opposite of the right angle is the diagonal. So 52 will be on one side. 52 squared will be on one side on its own. And then on the other side, we'll have the leg squared plus the other leg squared. So we have h squared plus h plus 28 squared equals 52 squared. Now let's do some simplification, because now we have an equation with one variable, and we're going to be able to solve for that variable. We have h squared plus h plus 28 times h plus 28 equals 52 squared. 52 times 52 is 2704. And we'll multiply out h plus 28 times h plus 28. That's h squared plus 28h plus 28h plus, let's see, 28 times 28 is 784. I'll combine like terms. H squared plus h squared is 2h squared. 28h plus 28h would be 56h. And I want to move this constant to the other side. So I'm going to subtract 2704. So 784 minus 2704. Negative 1920. Let me make that line up a little bit better. We have 2h squared plus 56h minus 1920. I have a quadratic equation which I want to solve. I'm going to try to solve this by factoring, but first I noticed that all of these numbers are even, so I'm going to be able to divide by 2. This is going to make my number smaller and much easier to work with in regards to factoring. So I divided 2 into 2h squared to get h squared. I divided 2 into 56 to get 28, and I divided 2 into 1920 to get 960. And now I'll try to factor. I know that these positions in the front of the binomials need to multiply to be h squared, so that'll be h and h. The numbers at the end of the binomial need to multiply to be 960. I'm not familiar with the factors of 960, so I'm going to go through step by step and list out the factors, and I'm looking for a pair of factors that will get me a 28 in the middle. So I'm going to start with 1 and 960. That clearly will not get me 28. And then 2 times 480 is 960, and that's not going to get me 28. 3 will divide into there. That's 320. That's not going to work. 4 into 960. And by the way, I'm just typing this in my calculator. 960 divided by 4 is 240. I know 5 will go in there. 192. 6 will go in there. The 160. I know we're getting closer. I don't think 7 goes in there, but let's just try it. Nope. About 8. 8 times 120. I don't think 9 does. Nope. 10 does. 10 times 96. Okay, I don't think 11 does. 12 does. 12 times 80. And what I'm looking for, just so you know, when I'm saying it's getting closer, I'm taking the difference between these two numbers, and we're hoping the difference between them is 28. So 13 doesn't work, 14 doesn't work, 15 does. 15 times 64. Okay, no. 16 times 60. 17 doesn't work. 18 doesn't work. 19 doesn't work. 20, and 48. And I think that's the pair that we've been looking for, because 48 minus 20 is 28. So I could get the middle number correct. I would need to have a 20 and a 48 with a plus and a minus. And I'll set each factor equal to 0. And I'll add 20 to both sides. That gives me h equals 20. I'll subtract 48 on both sides. That gives h equals negative 48. And it doesn't make sense for the height of the television set to be negative, so we can throw this solution away. And so that narrows it down to the height of the television set being 20. Now let's go back and read the question to make sure that we answer it completely. The question says, find the dimensions of the TV set. So we want to know the height and the length. We've got the height being 20, but the length will be right here, h plus 28. So we have the height being 20 inches and the length being 20 plus 28 inches, and that's 48 inches. So the dimensions of our television set are 20 inches high by 48 inches in length. In this question, we want to use the quadratic function f of x equals negative 1/6 x squared plus 8x minus 5 to address these following questions. We want to find the vertex using the vertex formula. We want to know the orientation, meaning whether that parabola opens up or down. And we also want to find the axis of symmetry. So let's start off by stating what the vertex formula is. If we have a quadratic function in standard form, general form, ax squared plus bx plus c, then the vertex will be an ordered pair hk, and we have a formula for the x-coordinate, and that's negative b over 2a, and then for the y-coordinate, we're just going to substitute that value of the x-coordinate into the function to get the y-coordinate. So that's what we're going to be using on this quadratic function. So in this example, we have a being negative 1/6, that is the coefficient on the x squared term, b being 8, the coefficient on the x term, and c being negative 5. So let's use the vertex formula, negative b over 2a, and b is 8, negative 8 over 2 times negative 1/6. So we'll simplify. In the denominator, we have negative 2/6. And when you have a fraction inside of a fraction like this, we call it a complex fraction. And what we'll do is we're going to treat this big fraction bar as a division symbol. So let's rewrite this as negative 8 divided by negative 2/6. And then we can rewrite division of fractions as multiplication. That's negative 8 times negative 6 over 2. And negative 6 over 2 is negative 3. And negative 8 times negative 3 is a positive 24. So we've got that the x-coordinate of our vertex is a positive 24. Then we can get the y-coordinate by substituting that value into the function. So this is going to be f of 24 negative 1/6 times 24 squared plus 8 times 24 minus 5. I'm going to get my calculator out to know what 24 squared is. So we apply the exponent first, and that's 576. And 24 times 8 is 192. And I need to know what 576 divided by 6 is. That is 96. So we've got negative 96 plus 192 minus 5. And 192 minus 96 is 96. 96 minus 5 is 91. So now we've got our vertex being 24, 91. So we've got part A done. Then we want to know the orientation. And we can know the orientation based on the coefficient of the squared term a. So because a is a negative 1/6, because that is less than 0, we know that the orientation of the parabola will be down, or opens down. And the axis of symmetry, when we have a parabola, either up or down, it doesn't matter which one, the vertex is the kind of balancing point or symmetry point. So if we were to take a vertical line passing through that vertex, what we find is a mirror image on either side of that line. So we can use the x-coordinate of our vertex to establish this axis of symmetry. So the axis of symmetry is a vertical line, and all vertical lines have the equation of x equals. And we're going to use that x-coordinate from the vertex as the axis of symmetry. Use transformations of y equals 1 over x or y equals 1 over x squared to sketch the rational function. Find all intercepts and the equations of all asymptotes. The function that we are trying to graph is f of x equals 1 over x minus 1 minus 4. And we want to graph this using transformations of either 1 over x or 1 over x squared. And the fact that we don't have an x squared or any squared in this function tells me we're going to be using 1 over x. And you can see the x in the denominator is matching the x in the denominator here. So our base function is going to be y equals 1 over x. And it's important for us to recognize what the graph of this function is first to help us understand how it's transformed. So what I know about this graph is that it is undefined at 0, and it has a vertical asymptote at 0, x equals 0. And it also has a horizontal asymptote at 0, that's y equals 0. And then the graph looks like this. So that's what the graph starts off looking like. Now we have two transformations. We have a -1 and we have a -4. And these transformations, because they're being added and subtracted, are going to be shifts. And one of them is a vertical shift and one of them is a horizontal shift. The way that we tell the difference is when one of them is on the inside and the other's on the outside. So this one here is inside of our fraction, inside of our base. So this one is going to be horizontal. And the -4 is happening away from that fraction, and that's outside of the base, and that is vertical. And then we want to know for the horizontal shift whether it's shifting left or to the right. The minus is to the right. So the graph is going to transform by shifting 1 unit to the right. And the -4 is either up or down, and the fact that it's minus means it's down. We're going to go down 4. So that's how we're going to transform this graph. And the way that I like to think about it is using this point where the two asymptotes cross each other, that's 0, 0. And to perform these two transformations on that anchor point. So we're going to take that anchor point and we're going to shift it to the right 1 and down 4. And that is our new location where the asymptotes will cross each other. So that's going to help me to know that the vertical asymptote is now x equals 1, and the horizontal asymptote is y equals -4. And then from there, the graph will look just like it did before, it's just got a new location. It's now kind of centered around this point 1, -4, instead of centered around 0, 0. So we have our graph, and we have our asymptotes. So the last thing that we need to do is find our intercepts. And just by visually inspecting our graph, you can see that we're going to have an x-intercept around here, so somewhere in between 1 and 2, and we're going to have a y-intercept somewhere around here, but let's find the intercepts algebraically. So remember our function is f of x equals 1 over x minus 1 minus 4. And I'll start off finding the y-intercept by letting x equal 0. That's going to give me f of 0 equals 1 over 0 minus 1 minus 4. That's 1 over negative 1 minus 4. Negative 1 minus 4 is negative 5. And so now I can see my line was getting a little off there. At 0, negative 5 is where that y-intercept is. Then let's find the x-intercept. To find the x-intercept, we let y equal 0. We're using function notation, so we're letting f of x equal 0. That's 0 equals 1 over x minus 1 minus 4. I'm going to solve this by adding 4 to both sides. That gives 4 equals 1 over x minus 1. I want to solve this by clearing fractions. I can do that by multiplying both sides by the denominator. So multiply x minus 1 on the right and x minus 1 on the left. So that's going to give 1 equals 4x minus 4 when I do the distributive property. I'll add 4 to both sides. That's going to give 4x equals 5. Divide by 4 and x equals 5 over 4. So that would be the x-intercept. Let me zoom out so we can see the whole problem. And we've got the graph, the asymptotes, and the intercepts. Jim wants to build a rectangular parking lot along a busy street, but only has 2,400 feet of fencing available. If no fencing is required along the street, find the maximum area of the parking lot. So Jim wants to build a rectangular parking lot. I'm going to draw a picture that is along a busy street. So I'm going to put the street here. And it says that he doesn't need fencing along the street. So let's get rid of the fence here. We want to find the maximum area of the parking lot. So let's label some sides. Let's call this the width of the parking lot. And let's call this the length. And our goal is to find the maximum area. So we need something to represent the area of that parking lot. The area of the parking lot will be length times width. We have too many variables in our area formula right now, so we're going to use some other information from the problem. We have 2,400 feet of fencing, and the fencing is going to go along these three sides here. So we know that 2,400 is going to equal 2 of the widths and 1 length. And I can use this information to reduce the number of variables in my area function. So what I'm going to do is I'll solve for length. I'll subtract 2w on both sides. That gives me length is equal to 2,400 minus 2w. And now I can substitute this length into the area equation. I have area equals 2,400 minus 2W times W. And if I distribute that W, we have 2,400W minus 2W squared. Now this is really, really great because now if I rewrite this, I have a quadratic negative 2W squared plus 2,400W. And I had a quadratic even before I rewrote it. But the fact that I have that squared means that I have area as a quadratic. And this is great because all quadratics have the graph of a parabola. And this particular parabola has a leading coefficient that is negative, and that means that it is oriented down. And the reason why that's so great for us is, remember, we're looking for the maximum area, and because it's oriented down, we're going to be able to say that the max is going to occur at the vertex. And so we have a way of figuring out that vertex. We're going to use the vertex formula. The vertex is going to be an ordered pair HK, and we can find that x-coordinate of the vertex using the formula negative b over 2a, and we're going to find the y-coordinate of the vertex by substituting that value of h into the area function. Now in this example, a is negative 2, that's the coefficient on the squared term, and b is 2,400, that's the coefficient on the linear term. So the x-coordinate of the vertex is negative 2,400 divided by 2 times negative 2. That's negative 2,400 divided by negative 4, and that's going to be 600. And then we can find the area by substituting 600 into the area function. We don't actually need the area in this problem. It's only asking for, oh, it is asking for the area, so we do need that. So right here it says find the maximum area. So we're going to substitute 600 into the area function. That's negative 2 times 600 squared plus 2,400 times 600. So we've got negative 2. We're going to apply the exponent first. And 600 times 600 is 360,000. We want to do 2,400 times 600, which is really big, 1,440,000. And we want to do 2 times 360,000. That is 720,000, and that's negative. And we need to do 1,440,000 minus 720,000 to get 720,000. So we need the width of this parking lot to be 600 feet, and the maximum area of this parking lot will be 720,000 square feet. On this question, we want to find the equation of all horizontal asymptotes of the rational function. And the rational function we have is f of x equals x squared minus 169 over x plus 13. Now, in this example, we're going to be finding the horizontal asymptotes in an algebra class. So the actual math behind finding horizontal asymptotes involves an operation called the limit, and that's something that you learn how to do in calculus. So in an algebra class, what we do is we try to summarize the rules so that we can find the asymptotes by following these different scenarios. So these rules that we follow involve looking at the degree of the numerator and the degree of the denominator. So you'll notice that in all of these rules we're using n and m, and those are the degree of the numerator and the degree of the denominator. So let's take a look. In this example, the degree of the numerator, n, is equal to 2. That's the highest power on x. And the degree of the denominator is 1, and that's the highest power on x. So if we're thinking about these different cases, I think it's pretty easy for us to eliminate n equals m. And I apologize there. I wrote this as n. It should be m. So I think it's clear to see that they're not equal to each other. But we need to figure out which of these other ones we have. Okay, so when we look at this first one, n is less than m. So I'm going to translate that to words. That says, it's actually right here. The degree of the numerator is less than the degree of the denominator. The degree of the numerator is less than the degree of the denominator. You can see that that's not true. And in the next one, if we put that in words, the degree of the numerator is 1 more than the degree of the denominator. So in this case, the degree of the numerator is that 1 more, that's a plus 1, 1 more than the degree of the denominator. And I can see that this is true. The degree of the numerator is 1 more, 1 bigger than the degree of the denominator. So this one is the one we want to use. So in that case, there is no horizontal asymptote. It does have what we call an oblique asymptote or a slant asymptote, but this question only wants to know about horizontal asymptotes. So on this one, we can say that there is no horizontal asymptote. We want to find the vertical asymptotes and create a rough sketch of the graph near each asymptote. And we're doing that for the function f of x equals x minus 7 over x squared minus 49. Now, when we're finding vertical asymptotes, we're going to have a rational function, and we need p of x and q of x, which is the numerator and denominator, to have no common factors. And in this example, I can see that it does have common factors. So if I factor out the numerator, well, the numerator's already factored, but the denominator is the difference of squares. That's x plus 7 times x minus 7. So before finding vertical asymptotes, I need to cancel out those common factors and write this rational function in lowest terms as 1 over x plus 7. So then, once I've done that, I'm going to look for a 0 of the denominator, and that 0 is going to be the vertical asymptote. So I've given the instructions here in detail. You want to factor the numerator and denominator, cancel out any common factors so that you don't have common factors. Then you're going to set the denominator equal to 0 and solve, and whatever solutions we get, those are vertical asymptotes. So we're going to take that denominator, set it equal to 0. So x plus 7 equals 0, subtract 7 on both sides, and we get x equals negative 7. So this function has a vertical asymptote at x equals negative 7. So a very common mistake would be to forget to cancel out that common factor, and you would come up with a second vertical asymptote, which is wrong, of x equals 7. So that is not a vertical asymptote. Something different is happening at that restricted value, and that at that value of x equals 7, we get what's called a removable discontinuity, which is a fancy word for a hole in the graph. So this particular function only has one vertical asymptote, and it's at x equals 7, negative 7, excuse me. Now we also want to come up with a rough sketch of what's happening near each asymptote. So what I want to do is I'm going to draw my number line, and on the number line I'm going to mark out where negative 7 is. And at that value, we're going to have that vertical asymptote. And as long as I know the definition of the vertical asymptote, I'll be able to figure out how to sketch the graph near it. So for the definition, we know that as x is approaching that number, in this example, negative 7, y is either going to approach infinity or negative infinity. So I know that the graph will go to infinity or it will go to negative infinity. It's not going to be all four of these. I need to figure out which ones are right and which ones are wrong. So the way that I do that is I want to pick a sample point or a test point on each side of the line to figure out which one's right and which one's wrong. So if I pick a number a little bit more than negative 7, like negative 6.9, and substitute it into my function, that would give me 1 over negative 6.9 plus 7, and that's 1 over 0.1, and that's going to give me a positive value. A positive divided by a positive is a positive. So that tells me that the positive one I've drawn is correct, and I'm going to get rid of this negative one. And then I'm going to do the same thing on the other side. Let me pick a sample point that's a little bit less than negative 7, like negative 7.1. And we're going to substitute that in. 1 over negative 7.1 plus 7 would give me 1 over negative 0.1, and that's a negative number. So I know on the left side that the negative one is right, and I need to get rid of the positive one. So I know that near the vertical asymptote of x equals negative 7, on the right side it's going to positive infinity, on the left side it's going to negative infinity. Thank you for checking out my videos. Have a great day.